Hi everyone, welcome to the channel. Today we're diving into a topic that's revolutionizing how we interact with artificial intelligence. Have you ever chatted with an AI and received an answer that was a bit off? Maybe it was outdated, completely made up, or just not relevant to your question. It's a common problem, and it happens because most large language models, or LLMs, are trained on a fixed set of data. They don't have real-time access to the vast, ever-changing world of information. But what if there was a way to give these powerful models a direct line to current, reliable knowledge? Well, there is, and it's called Retrieval-Augmented Generation, or RAG for short. Let's break down what that actually means. Think of a standard LLM as a brilliant student who has memorized every book in a library up to the year 2021. They can write amazing essays, answer complex questions, and even get creative. But if you ask them about something that happened yesterday, or a niche topic that wasn't in their library, they might struggle. They might guess, or they might just say they don't know. RAG changes this completely. It's like giving that brilliant student a super fast, always-on internet connection and teaching them how to do a perfect search before they answer any question. So how does it work? The process is fascinatingly simple in concept. It has two main stages, retrieval and generation. First, let's talk about retrieval. When you ask a question to a RAG-powered system, it doesn't immediately try to generate an answer from its internal memory. Instead, the first thing it does is use your query to search through a massive, up-to-date knowledge base. This could be anything. The entire internet, a company's internal documents, a collection of legal texts, your personal notes, you name it. The system looks for the most relevant pieces of information related to your question. It's like a hyper-efficient research assistant finding the exact paragraphs and data points you need. Once the system has retrieved this relevant information, we move to the generation stage. This is where the magic of the large language model comes back into play. The LLM takes your original question, combines it with the specific, relevant information it just found, and then crafts a coherent, accurate, and context-rich answer. It's not just spitting back the search results, it's synthesizing them. It's using the retrieved documents as a source of truth to formulate a brand new, human-like response. So, instead of guessing, the AI is now answering based on solid, verified information. This simple two-step process makes the AI's responses dramatically more reliable and trustworthy. Let's use an example. Imagine you ask a standard LLM, what were the key findings of the latest climate report released last week? A model trained a year ago wouldn't have a clue. It might apologize for its lack of current information or even hallucinate an answer based on older reports. Now, let's ask the same question to a RAG system. First, the retrieval part kicks in. It searches a database of recent news articles and scientific publications, finds the documents about last week's climate report, and pulls out the key findings. Then, the generation part takes over. The LLM reads your question and the retrieved findings and says something like, the latest climate report highlighted 3 major findings. Rising sea levels are accelerating faster than previously projected. There's been a record increase in greenhouse gas concentrations, and you get a precise, factual, and timely answer. The benefits here are huge. The most obvious one is accuracy. By grounding the AI's answers in real, retrievable documents, RAG drastically reduces the chances of hallucinations. That's the term for when an AI confidently makes things up. This is incredibly important for applications where facts matter, like in medicine, law, finance, or even just for getting reliable homework help. You can trust the answers more because you know they are based on a specific source, and some systems can even cite their sources for you, just like a good research paper. Another major advantage is that the knowledge base can be updated easily. To update a traditional LLM, you have to go through a very expensive and time-consuming process of retraining the entire model on new data. With RAG, you don't need to retrain the core model. You just update the knowledge base it retrieves information from. If a new policy is introduced in your company, you just add the new policy document to the database. Instantly, the AI can answer questions about it. This makes RAG systems incredibly flexible and cost-effective to maintain. They can always stay current without a massive overhaul. If you are still watching, you must be curious to know more about the fascinating technology we are discussing. Subscribe to the channel so you don't miss out on more deep dives like this one. Now, let's explore where RAG is being used. The applications are practically limitless. Customer support is a big one. Instead of generic chatbot responses, a RAG-powered bot can search a company's product manuals, FAQs, and troubleshooting guides to give customers specific, helpful answers to their problems. This leads to happier customers and a reduced workload for human support agents, who can then focus on more complex issues. In the world of business intelligence, employees can use RAG to query massive internal databases and reports in natural language. Instead of needing to know complex database query languages, a manager could just ask, "What were our top-selling products in the European market last quarter, and what was the customer feedback?" The RAG system would retrieve the sales data and customer review summaries, then synthesize a comprehensive answer. This democratizes access to data and empowers faster, more informed decision-making across an organization. For researchers and students, RAG is a game changer. Imagine writing a research paper and having an AI assistant that can instantly find, summarize, and synthesize information from millions of academic articles. It can help you find supporting evidence, identify counterarguments, and explore related topics you might have missed. It accelerates the research process and helps produce more thorough and well-supported work. Of course, RAG isn't a perfect solution, and it has its own set of challenges. The quality of the retrieval step is absolutely crucial. If the system fails to find the right documents, the LLM won't have the correct information to generate a good answer. This is the classic garbage in, garbage out problem. So, a lot of engineering effort goes into optimizing the retrieval process, making sure the search is fast, accurate, and can understand the nuance of the user's query. Another challenge is handling conflicting information. What happens if the RAG system retrieves two documents that say opposite things? The LLM needs to be sophisticated enough to recognize the conflict and, ideally, present both sides of the story or ask for clarification. It also needs to handle the sheer volume of data. Sifting through terabytes of information to find the perfect snippet in milliseconds is a significant technical feat. This involves advanced techniques like vector embeddings, which turn words and sentences into numerical representations, making it easier for a computer to understand semantic relationships and find similar concepts. So, let's recap the entire workflow in a bit more detail. It begins with your query. That query is then transformed into a numerical format, a vector. The system then uses this vector to search a pre-indexed vector database of the knowledge source. The database returns the chunks of text that are most similar or relevant to your query's vector. These retrieved chunks, along with your original query, are then bundled together into a new, expanded prompt. This enriched prompt is what gets sent to the large language model. The LLM, now armed with specific context, generates the final answer that you see. It's an elegant pipeline that combines the best of search technology with the best of generative AI. The future of RAG is incredibly exciting. Researchers are constantly working on making it better. They are developing more advanced retrieval methods that can understand more complex questions. They are also working on hybrid approaches, where the system can decide whether to use its internal knowledge, perform a search, or even ask clarifying questions before answering. We're also seeing RAG being integrated into more and more applications, from search engines to personal assistants, making our interactions with technology smarter and more reliable. In essence, Retrieval-Augmented Generation is a bridge. It connects the powerful but isolated minds of large language models to the dynamic, ever-expanding universe of human knowledge. It's a practical and powerful solution that addresses some of the biggest limitations of AI today, making it more factual, transparent, and useful in our daily lives. By ensuring that AI-generated content is grounded in reality, RAG is a critical step towards building AI systems that we can truly trust and collaborate with. Thank you so much for joining me on this deep dive into Retrieval-Augmented Generation. I hope this has given you a clear understanding of what it is and why it's such a big deal. If you found this video helpful, please give it a thumbs up and consider subscribing for more content on the latest in tech and AI. Let me know in the comments what you think about RAG or what other AI topics you'd like me to cover.